We like to imagine the history of human progress as a straight line. We picture the scientist as a stoic figure in a pristine lab, moving logically from hypotheses to experiment, and finally, to a calculated breakthrough. But history tells a different story. It's a story not of straight lines, but of stumbling blocks, written in spilled chemicals, forgotten petri dishes, and lenses dropped by clumsy hands. The greatest leaps in our civilization were often not the result of looking for something, but of finding something else entirely. This is the chronicle of the flicker of genius, the moment when the prepared mind collides with pure, chaotic chance. This is the story of how accidents built the modern world. Our journey begins not in a high-tech facility, but in the dusty workshop of a spectacle maker in the Netherlands. Back in 1608, Hans Lippershey was a busy man, grinding glass to correct fading vision. Legend says he didn't invent the device that would change our view of the heavens by staring at the stars. He did it because he was annoyed by the noise of children. 2 kids were playing in his shop, picking up different lenses. In a moment of idle play, they held them up in a line, looking toward the distant church tower. Suddenly, they shrieked in delight. The Weather Vane, usually a blurred speck, appeared to be right in front of their faces. Lippershey, startled, took the lenses from their hands and aligned them just as the children had. The world jumped forward. He wasn't trying to see the craters on the moon. He was just making reading glasses. But in that accidental alignment, the telescope was born. When news of this device reached Italy, a mathematician named Galileo Galilei refined it, turned it upward, and shattered the ancient belief that the Earth was the center of everything. Fast forward 3 centuries to London, 1928, in the lab of Alexander Fleming. Fleming was a brilliant bacteriologist, but he was not a tidy one. His workspace was a chaotic landscape of unwashed equipment and cultures of Staphylococcus bacteria. He decided to take a 2-week vacay on, and in his haste, he didn't clean up. He left a stack of petri dishes sitting out on a bench, and crucially, left a window slightly ajar. For 2 weeks, London's air drifted through that window, carrying dust, pollen, and spores. One specific spore settled gently onto one of the dishes. When Fleming returned, he began the tedious task of cleaning up. He grabbed the contaminated dish, sighed at the fuzzy mold growing on it, and prepared to wash it away. But then, he stopped. "That's funny," he muttered. Most scientists would have seen a ruined experiment. Fleming saw a battlefield. Around the blue-green mold, the deadly Staphylococcus bacteria were gone. A clear halo of safety surrounded the mold. The mold was Penicillin nototum, and it was releasing a juice that killed bacteria. That single funny moment saved an estimated 200 million lives in the 20th century alone. Next, we jump to World War II. In 1945, Percy Spencer, an engineer at Raytheon, was working on a key component of radar systems designed to spot enemy planes. It was serious, military tech. One day, Spencer was standing in front of an active magnetron set when he felt a strange sensation against his leg. He reached into his pocket. He had stored a peanut cluster bar there for a snack, but when he touched it, he found a sticky, hot mess. The room wasn't hot, and he wasn't touching the machine. He suspected the invisible waves were responsible. To test his theory, he sent a boy to fetch some popcorn kernels. He placed them in front of the magnetron, and within seconds, they began to pop, dancing all over the lab floor. Next, he tried an egg. It exploded in a colleague's face. The conclusion was undeniable. The radar waves were agitating the water molecules inside the food, creating heat. The device meant to track bombers was repurposed to heat up leftovers. The Red Orange was born, all because the scientists liked chocolate and stood in the wrong place at the right time. Sometimes, serendipity saves us from physical harm. In 1903, a French chemist named Edouard Benedictus was climbing a ladder in his laboratory when he knocked over a glass flask. It fell to the hard floor, a distance that should have resulted in a dangerous explosion of sharp shards. He flinched, but he didn't hear the usual scattering. He looked down. The flask was broken, cracked in a spiderweb pattern, but it held its shape. He realized the flask had previously contained a solution of liquid plastic which had evaporated, leaving a thin, invisible film coating the inside. This film held the broken pieces together. He noted it, but didn't think much of it until he read a newspaper article about a car accident where a woman was badly injured by the flying glass of her windshield. The memory of the dropped flask flashed in his mind. He immediately set to work creating a glass plastic sandwich. Today, we call it safety glass. Every car windshield and every pair of safety goggles exists because a clumsy chemist dropped a bottle and was observant enough to wonder why it did unshatter. In 1856, William Perkin was an 18-year-old chemistry student given a difficult assignment. Synthesized quinine, the only treatment for malaria. Working in his home lab, he mixed coal tar derivatives, trying to create a colorless medicine. Instead, he produced a thick, black, sticky sludge. It was a complete failure. Disappointed Perkin began to wash out the flask with alcohol. As the alcohol hit the sludge, something magical happened. The mixture turned a brilliant, vivid purple. At the time, purple dye was reserved for royalty because it was so hard to make. But here, in a failed malaria experiment, was a stable, vibrant purple. Perkin forgot about malaria. He patented the color, calling it Mauvine. It launched the synthetic dye industry, revolutionized fashion, and made him a rich man. More importantly, the science of synthetic dyes led directly to the development of modern chemical medicine. By failing to cure malaria, Perkin inadvertently created something far greater. Our final story takes us from the microscopic to the infinite. In 1964, Arno Penzias and Robert Wilson were radio astronomers using a massive horn antenna to map signals from the Milky Way. But they had a problem. No matter where they pointed it, they picked up a persistent, low-level hiss. They checked the wiring. They pointed it at New York City. They even climbed inside and scrubbed off what they politely called white dielectric material pigeon droppings. They evicted the pigeons, cleaned the device, and turned it back on. The hiss was still there. Day and night, summer and winter, it was coming from everywhere. Frustrated, they called a physicist at Princeton University, Robert Dick. When Dick heard their description, he put down the phone and told his colleagues, "Boys, we've been scooped." Dick had been theorizing that if the Big Bang happened, there should be a leftover echo permeating the universe. Penzias and Wilson weren't listening to faulty wiring. They were listening to the sound of the universe being born 13.8 billion years ago. They had accidentally discovered the cosmic microwave background, the strongest evidence for the Big Bang. What binds all these stories together? It isn't just luck, as Louis Pasteur famously said. In the fields of observation, chance favors only the prepared mind. These discoveries required the humility to stop when things go wrong, and the curiosity to ask why. They teach us that progress isn't a rigid plan. Sometimes, the universe speaks to us in a whisper, a broken flask, or a ruined experiment. And sometimes, the flicker of genius is simply the willingness to listen to the accident. Thanks for watching. And if you enjoyed this journey into the unexpected, be sure to subscribe for more.